Alright, starting with number 8. We've got an intersection where a car traveling west collides head-on with a minivan traveling east, and they stick together. Oh, so perfectly inelastic. If they stick together, or totally inelastic. And they move with this velocity east after the collision. What is the mass of the minivan? Alright. So I'm going to start off with the written part. Is a totally inelastic collision. So momentum is conserved, but not kinetic energy. The two cars become a single body after the collision. Let's see if there's anything else that's in there. They move east afterwards. I'm going to take a guess, but I think since they move east after the collision, the minivan had more momentum than the car. As if together, if you got east and west coming together and then they continue east, it would seem like the east won. So it would have more momentum going in than the car did. Any questions on the writing part that I did? Alright, so let's see, the car was the one heading west, right? So, let's see where the drug. Now remember, don't be intimidated by my artistic ability. You too, after years of practice, to be able to draw that good of a car, that good of a minivan. So that would be heading east. And that good of a car. So I'm going to call that the momentum of the mini car. This would be the momentum of the car. And that's the momentum of the minivan. And those would be my diagrams. Questions, comments, critiques? Thank you. My minivan is a little weird, but... Alright, let me grab those and throw them in my documents. That's before... That's after. Alright. Let's see. From my equation sheet, I can grab the momentum of the system before equals the momentum of the system afterwards. You probably grab that momentum is inertia times velocity. Yeah, that's all I need. So beforehand, which way do we want to say it's positive? To the right or east? Okay. That's what I want. So that means if I add the momentum of the minivan to the momentum of the car, that will equal momentum of the minivan and the car. But I need to take into account that the momentum of the car is negative, because I'm defining to the right as positive. So when I put this in, I'm going to put negative whatever value that is. And so I just have a positive value there, and I'm going to expect and get a positive value out. Now I touched it. Let's see. Mass of the minivan, velocity of the minivan, minus mass of the car, velocity of the car, equals, this is the mass of the mini car and the velocity of the mini car. And of course that mass of the mini car is the mass of the minivan plus the mass of the car. You know P is the symbol for momentum. We've had multiple discussions about that. I even published a finding on that for you. Right, and now you just substitute in. Right? So I'll do mine, you do yours. Let's see. 1280 car, 12. So mm 9.4. Alright, I got 2190 for mine. I want to check and see if that makes sense. So I'm going to take that 2190 times 9.4. And I'm going to do that 1280 times 12. And my minivan did have more momentum than my car before the collision, so it makes sense to me that they would continue on in the direction the minivan was moving afterwards. So kind of my check there to see, does my answer even make sense, works. Now I can check and see, is it actually correct? 2190, 2 sig figs, so 2200. Yay! Alright, on to number 2. We got the hockey player. He rests on the ice, tosses the helmet directly in front of him. Speed of this, and recoils at the speed of this. Oh, we have an explosion! Cool. Kind of a minor one, but it is an explosion. So that's what I'm going to start off with. This is an explosion. Momentum is conserved. The momentum starts at 0 and must remain 0 after the explosion, so direction will be very important. So I know because he was just standing there arrested, the whole system has no momentum. Explosion happens, momentum still has to end up being 0. Does that mean the momentum of the helmet is 0? No. But the whole thing together must end up being 0. Alright? So, diagram was ice. Give him some ice skates. The helmet. Afterwards, momentum of the helmet. What do they call it? We'll call him a hockey player, H. Here we know the momentum is 0. Yay! There we go. Good? On the line? Liam, do you agree? Or are you not? Are you working on a different one? Okay, never mind. Sorry. Good? Alright, let's see. From my equation sheet, momentum of the system before equals the momentum of the system after. Momentum mass times velocity. So, beforehand, technically this is a hockey player and helmet. Whoops. We'll change that to HP. So, momentum of HP equals, now, momentum of HP, the vector plus momentum of H, the vector. Which direction do we want to call positive? Anybody? To the right? Excellent. The direction the helmet went in. Yeah. Alright, so I know this is 0. This one will be negative, so negative PHT plus a positive PH. I feel like it's chemistry now. This would be mass of hockey player, velocity of hockey player, and I know that it's negative plus mass of helmet, velocity of helmet, and I know that that is positive. I get rid of this little vector symbol. And now again it's substituting in, right? That's what I'm looking for. 6 meters a second, 1.2.3. Now I'm going to make a prediction, just doing it in my head. 10 times, 20 times as large. I think the hockey player is going to have a mass 20 times as large as that helmet. So I'm predicting 240. And the way I did that is I looked at my velocities, and my velocity of my helmet is 20 times the velocity of my player. So the inertia of the player must be 20 times the great as the inertia of the helmet. Hope I'm right. Oh. Did I put in something wrong? Hmm. 1.2, 6, 0.3, oh, I put in 60 into my calculator. And got 20, I should have gotten 24. Ah. Wow, it's not liking me right now, so I'll fix that in a minute. There we go. which is 20 times greater. That's what I put in was 200 times greater. Whoops. Alright, on to number 1. 2 canoes. Push away. Ah! We have another explosion. Wow. A canoe explosion now. I think I'll grab this. Put it here. And let's see. Canoe 1 moves at this, and Canoe 2 moves slower. I'm going to predict that the mass of Canoe 2 is more than twice the mass of Canoe 1. The mass of, I should probably put I predict. The mass of Canoe 2 is more than twice mass of Canoe 1. We'll have to see if that works out. Oh boy, I gotta draw canoes now. Alright. There are my canoes. I know they're fancy. Oops. Thanks. Which way do you guys want to call positive? To the right? Call that direction positive. Good. The exit ticket is up live. If you would do that, that would be very helpful. I'll do my math here and then upload it afterwards. And as predicted, a little over twice as much. See if it's right. 2 sig figs.